So let's talk about set theory. And first, let me start by describing what sets are. A set is basically a group of objects. Now, objects could be anything like colors, animals, places. So you can have a group of cities, for example, or a group of farm animals, or a group of colors that you like, and these things would be sets. Now, of course, we're in math class, so our sets are going to be groups of numbers. And generally speaking, these are going to be numbers that follow a pattern. Now, an example of a set would be uh, 0, 2, 4, 6, 8, etc. Now, we indicate that a set exists because of these brackets here. These are called curly brackets, and the things we put inside the curly brackets belong to this set. And the things inside the set are called elements, and we usually separate each element with a comma. These three little dots means etc., but it means also follow the pattern. So here what we're doing is we're counting by twos, and what we're getting is all the even numbers. So this is basically the set of all positive even numbers. So this is equal to set of all positive even numbers. Um, Another set would be, for example, -1, -2, -3, -4, etc. This is the set of all negative integers. Now, you've already seen a couple sets before, and one example of such a set is this one over here. This is called the set n of natural numbers. So it starts with 0, 1, 2, 3, 4, 5, etc. So what it is basically all the positive integers, including the 0. So basically starting at 0 going to infinity, positive integers. And this over here, the symbol n here, is basically the letter n with an extra line next to it. And this is called blackboard bold. So we put an extra line next to a letter to indicate boldness. So instead of writing in bold, because I can't, I write blackboard bold by adding an extra line. So if I were to draw some of these elements out, I'd have 0, I'd have 1, I'd have 2, 3, 4, 5, etc. And this would be inside my set, which I'll represent by this circle, and this would be the set of natural numbers. So this is natural numbers. It's also known as the counting numbers because we use these numbers when we count things. So I can start off by saying, oh, there's nothing of something, and then there's one of that thing, two of that thing, three of that thing, etc. Another set, much bigger actually, bigger than this one, is the set of integers, represented by the letter Z in blackboard bold. And it starts at negative infinity, goes to positive infinity, so -3, -2, -1, 0, 1, 2, 3, etc. So it starts at negative infinity, goes to positive infinity, and includes all of the natural numbers and all of the negative integers. So I would have, for example, -1 out here, -2, -3, -4, -5, etc. And these do not belong to the natural numbers, so I don't put them inside the set, but my set of integers incorporates both of these, so I have a circle around both of these sets. Now, a bigger set again is the set Q, known as the rational numbers, and this is the set, so the set of all fractions. So basically, a fraction looks like this, a over b, where a and b are integers. So a and b are integers. So uh, 2 over 3, 1 half, 1, 1 over 4. Actually, uh, 3 over 2 is a fraction also. Um, Actually, it includes all these numbers inside z and n because we can write all these numbers as being whatever you see divided by 1, which is a fraction. So here's our set of rational numbers. This is now the set Q. And um, the set that encompasses, that's, okay, so actually before I get there, there's another set called Q prime. This is all the irrational numbers. And that's basically saying all the numbers that are not fractions. Numbers, so this is numbers that are not fractions. And you're probably wondering what kind of numbers are not fractions, right? Because don't we have all the numbers here that are uh, that exist? Well, actually no, because um, there are numbers like square root of 2, square root of 3, square root of 5. So basically the square root of any prime number, so I'll write that as square root of p for prime. Also pi, also e. These are numbers. Pi is 3.14, etc. E is the natural base that we use in logarithms. These numbers have never-ending decimal numbers, while fractions either have an ending decimal, so a terminating decimal number, or a periodic number, like 1/3, for example. I'll put it in here, 1/3. 1/3 can be written as 0.3333 forever. And any decimal that's periodic, or any number that has a terminating decimal expansion, is a fraction, basically. It can be represented as a fraction. These numbers over here cannot be represented by Q, so they are their own set over here, called the irrational numbers represented by Q prime. And uh, finally, R is the set of all real numbers. And so this is not IR, and this is not IN, as most people confuse it. This is actually just bold R, and it represents the set of all real numbers, and it includes everything over here. So we have R, and R is made up of all of the natural numbers, all of the integers, all of the rational numbers, and all of the irrational numbers. And all of that all together is the set of real numbers.